Hello and welcome everyone to the quick solutions of All India AIATS Test Series Medical 2019. Test number 7, code E and F, dated 10th of March 2019. I'm here to discuss the physics portion. So let's get started. Let us proceed to the question number 1. So here we are having question number 1. To get 5 images of a point object, the angle between two plane mirrors may be what? We know very well, in order to calculate the number of images of an object placed between two mirrors having an angle theta between them is given by n equals 360 upon theta minus 1, or it may also be n equals 360 upon theta only. What formula we have to apply? It depends upon 360 upon theta. If this number comes odd, then we use this formula, and if 360 upon theta comes an even number, then we use the first one. Now here the number of images is already given, so we have to follow the reverse algorithm. How n can be 5? If we take theta as 60 degree, so somehow we get 360 upon theta as 6, and if we subtract 1 from 6 we get 5. So theta may be 60 degree, and therefore n equals 5, or 5 images we can get. So that's why we'll proceed with the first option, which is absolutely correct. Now let us proceed to the next question, that is question number 2. Here is question number 2. An object 2 cm tall is placed at a distance of 5 cm in front of mirror. In order to produce an upright image of 4 cm height, mirror required is what? So you are having 4 options and you have to pick up the correct one. See here, height of object is given. Object always kept above the principal axis. So according to sign convention, we can use height of object as plus 2 cm. On the other hand, height of image, the image mentioned in the question is upright, so obviously it will form above the principal axis. So HI will also be positive, that is 4 cm. You can get the magnification from here. We know very well that the magnification for mirror M equals what? Minus of V by U, which is further ratio of height of image upon height of object. Putting the values, we get minus V by U equals HI, that is 4, HO, that is 2. Object distance always negative given in the question, so minus V upon minus of U, that is 5, equals 2. So we got the value of V as 10 centimeter. Now V is getting 10 centimeter. Now let us calculate the radius of curvature. According to mirror formula, we know that 1 by V plus 1 by U equals 1 by F. Putting the values with proper sign convention, 1 by V, that is 10, plus of 1 by U, that is minus 5, equals 1 by F. So therefore 1 by F we can write 10, our LCM, 1 minus of 2. Focal length we have got minus 10 centimeter. Focal length is negative for concave mirror. So we have got the type of mirror that is concave. Therefore, concave mirror. And the option also contains radius of curvature. So let's calculate the radius of curvature. We know that radius of curvature is twice of focal length. So 2 into F, that is minus 20 centimeter. This negative sign shows that the mirror type is concave. So the answer will be a concave mirror having radius of curvature 20 centimeter. So we'll go with option number 3. Now let us proceed to the next question, that is question number 3. So here is question number 3. A ray of light is incident at an angle 60 degree on a prism of refracting angle 60 degree. If the refractive index of material of prism is √3, then angle between incident ray and emergent ray will be what? So indirectly we have to find out the angle of deviation. Suppose here we are having the prism. Incident ray incident at A. The normal will be here, something like this. Light will bend towards the normal, making an angle of refraction, suppose R1. Angle of prism is given 60 degree in the question. Angle of incidence is also given 60 degree. Now the light will refract again at point B, as there is change of the medium and it will bend away from the normal. So let's draw the normal here. It will bend away from the normal and this will become your angle of emergence. But we have to find the angle between incident ray and emergent ray. So this was incident ray. This is emergent ray. Indirectly we have to find out this angle. And for the prism, we know that the angle of deviation delta is given by I plus E minus of A. In the question, I is given, A is also given, but E we have to calculate anyhow. So let's calculate the value of E using the Snell's law. So applying the Snell's law at A. We will get the ratio of sine of incidence angle, that is 60 degree, divided by refractions sine R1 equals refractive index of refracting medium, that is √3 upon refractive index of incident medium, that is air. We can use 1 here. So after solving, we will get the value of R1 as 30 degree. Now we know very well that this angle and this angle, the angle at O, they will together makes 180 degree. Now consider this triangle. One is 120 degree. R1 you have calculated 30 degree. So this angle, which I am calling R2, will be what? Again 30 degree. So applying the Snell's law at B also, we will write the expression sine of incidence angle, that is R2 here, sine of refraction angle, that is E here, equals refractive index of refracting medium, that is air, 1 upon incident medium, that is √3. So R2 is already given, so we can calculate sine of E as √3 times sine R2, that is 30 degree. That is 30 degree. So therefore √3 multiplied by 1 by 2, √3 by 2. Therefore we can write the angle of emergence as 60 degree. Now plugging the values of all I, E and A in delta formula, we will get the deviation angle delta as I, that is 60, plus E, that is also 60, minus A, that is 6. So ultimately we will get the angle of deviation or the angle between incident and emergent ray 60 degree. So after looking at the options, we can say that we have to go with option number 2. Option number 2 will be absolutely correct. Now let us proceed to the next question, that is question number 4. Here is question number 4. The focal length of eyepiece and objective of an astronomical telescope are 4 cm and 50 cm respectively. The length of telescope for the adjustment in which eye is most strained will be about. We have to take least distance of distinct vision as 25 cm. Now we know very well that at near point eyes will be most strained. So that's why we'll take the near point. Now the length of telescope for near point adjustment is given by L equals F0 plus D times Fe upon D plus Fe, where Fo is the focal length of objective and Fe is the focal length of eyepiece. D, in this particular case, we have to take least distance of distinct vision, that is 25 cm. Now putting the values, we will get L equals 50 plus 4 into 25 divided by 4 plus 25. After solving, we will get an approximated value of 53 centimeter. And after looking at the options, we can say that option number 3 is absolutely correct. So that's why we'll go with option number 3. Now let us proceed to the next question, that is question number 5. Here is question number 5. Light takes time t1 to travel a distance a in medium 1 and takes time t2 to travel a distance b in another medium 2. The critical angle for the pair of medium is given that medium 2 is denser than the medium 1. Now, the speed of light in medium 1, that is v1, will be what? A upon t1. Similarly, the speed of light in medium 2, let's say v2, will be what? Distance upon time. Distance is b, time is t2. Now, it is already given in the question that medium 2 is denser than the medium 1. Then we can write, this is the interface. This is medium 2, which is denser. This is medium 1, which is rarer comparatively. Now, if it is talking about the critical angle, then the angle of refraction must be 90 degree. And angle of critical, that is critical angle, must be IC. Applying the Snell's law, what we will get? Sine of IC divided by sine of refracting angle, that is 90 degree, will be what? Refractive index of refracting medium, that is N1, upon refractive index of incident medium, that is N2. And N1 upon N2 ratio will be given by V2 by V1. We know very well. Now plugging the values, sine of IC equals V2, that is B by T2, divided by V1, that is A by T1. Solving, we get BT1 upon AT2. So sine IC, we have got this value. So therefore, the critical angle IC will be what? Sine inverse BT1 upon AT2. So after looking the answer, we can say that we have to go with option number 2, which is absolutely correct. So that's why we'll go with option number 2. Now let us proceed to the next question, that is question number 6.